Hello students and welcome to my channel Maths Hub. So I'll talk about multiple integration in this video, and in this video we will be specifically talking about the center of mass, right? So now what is center of mass? So you might have come across these terms: center of mass, center of gravity, centroid. So we will understand these definitions first for a thin plate and then for a solid body. Now all these terms are connected with the term that is called as first moment, right? So first moment is the balancing point of any object. So if you remember that, you might have done these terms in physics. So center of mass is where the entire mass is centered. Center of gravity is again the point where the entire gravity of the body is acting, right? And centroid is again the common point where the body gets balanced. So all these three terminologies, they are connected with the first moments, and all these terms are related to the balancing point of any object. So when I have a thin plate, so how do we calculate the first moment about the x-axis? It is calculated as mx is double integral y rho dA. So rho means the density of that object and dA is the area of a small portion of that object, right? So if I consider this body, so suppose I'll consider this surface over here. Sorry, I consider the surface over here. So what happens? The first moments about the y-axis would be simply double integral x rho dA. So if this is my object, right, this is the small area, I'll take its distance from the x-axis as well as the y-axis. So when we are calculating the moments about the x-axis, so it is written as mx and it is equal to double integral y rho dA, right? And when we are calculating the first moments about the y-axis, it is double integral x rho dA. So how do you calculate the point? The point is calculated as x bar is my upon m and y bar is equal to my upon m, where how do you calculate the mass of that object? The mass is calculated as double integral rho dA, right? So in general, how do you calculate x bar? Since it is my, so it is double integral rho x dx dy divided by double integral rho dx dy, and y bar is double integral rho y dx dy upon double integral rho dx dy, right? So with the help of these formulations, we can calculate the center of mass or maybe the centroid or maybe the center of gravity for any thin plate, right? Now let us come to these three definitions for a solid body. Now, when it is a solid body, so that means we are working in three dimensions. So the first moments about the YZ plane, it will be MYZ, and we have a triple integral now, rho x rho dV. Similarly, the first moment about the XZ plane is MXZ triple integral y rho dV. And the first moments about the XY plane is given as MXY, and it is triple integral z rho d, right? So from here, when we calculate these first moments about these planes, the mass is given by triple integral rho d, right? The density into the volume of that solid body. So from here, we get the points as x bar is myz upon m, y bar is mxz upon m, and z bar is mxy upon m. So when we put the values of these myz, mxz and mxy, we get x bar as triple integral rho x dx dy dz upon triple integral rho dx dy dz. Similarly, we get y bar as triple integral rho y dx dy dz upon triple integral rho dx dy dz. And z bar as triple integral rho z dx dy dz upon triple integral rho dx dy dz. So by now you have already known that this order matters. So whichever way you will write the three terms, you have to do the limits of integral accordingly, right? So let us move on to the question. So we have an exercise that find the center of mass of a thin plate of density rho equal to 3, bounded by the lines x equal to 0, y equal to 0, and the parabola y is equal to 2 minus x squared in the first quadrant, right? So let us first of all plot the diagram, because with the help of the diagram, the things become simpler. So y is equal to x is this line. And now what is y is equal to 2 minus x square, right? So I can take 2 on the other side and I get y minus 2 is equal to minus x square. Now this is a down parabola passing through the points 0, 2, right? So 0, 2 is somewhere here. So it's a parabola in this form, right? And we have another axis, that is x is equal to 0. So this is x equal to 0 is the y-axis. So the common region that we have in this is this region. This is the, I hope it is visible. Just let me mark it with a different colored pen. So this is your region of integration, right? Okay. So let us first of all calculate mass m. M is double integral rho dy dx. So when I take a strip over here, so I can see that the strip enters at x, y is equal to x, and this line is y is equal to 2 minus x square. So the strip is still 2 minus x square. And what are the limits of x now? So I need this intersection point. So I'll just solve 2 minus x square equal to x. I'll equate both of them. And from here, I get x square plus x minus 2 is equal to 0. So I have x square plus 2x minus x minus 2 is equal to 0. So x into x plus 2 minus 1 into x plus 2. So x is 1 or minus 2. So this point is 1, 1, right? So let me just clear this portion. And from here, we get the limits of x as 0 to 1, the minimum to the maximum limit, right? Rho is a constant, so I'm not putting the value. I'll just keep rho as it is. So when I integrate this, I get 0 to 1. Integration of dy is y. And when I put the limits, I get 2 minus x square minus x. And let us integrate it with respect to x. So rho is again constant. So when I integrate, I get 2x minus x cubed by 3 minus x squared by 2. Limits are 0 to 1. So when I put the value, I get 2 minus 1 by 3 minus half. So when I take the LCM, I'll get rho. 3 into 2 is 6 is the LCM. So I have 12 minus 6 divided by 3, 2 minus 3. So that is basically, and I can put rho as 3 over here. So when I put rho as 3, this term, so this is half. So 12 minus 5 is 7. So I will get my mass as 7 by 2, right? So now let us calculate mx. So mx is rho y dy dx, and you can see that the limits of integration will remain same, right? 0 to 1. Let us try to calculate this. So I can take out rho common, 0 to 1, or let me do it with a different colored pen so that it is easy for you to check it out, right? Okay, let me rewrite it again. So this is rho 0 to 1. Now when I integrate this, this is y square by 2. So 2 I can take out y square, and the limits are from x to 2 minus x square dx. So this is rho by 2, 0 to 1. When I put the values, I will get 2 minus x square whole square. So this is 4 plus x to the power 4 minus 4x square minus x square. Right? This is what I'll get. Integration with respect to x. So this is rho by 2. Integration of 4 would be 4x. Integration of x to the power 4 would be x to the power 5 by 5. 4x square, and this is 5x square. So when I integrate this, I will get 5x cubed by 3, limits from 0 to 1. So this is rho by 2. When I put the limits, I will get 4 plus 1 by 5 minus 5 by. So rho, the value is 3, 3 by 2. Let's take LCM 15. So this is 60 plus 15 divided by 5 is 3 minus 15 divided by 3 is 5. 5 into 5 is 25. So 3 and 1, 5 will come out, right? And we have this calculation would give. So this is giving me 19 by 5, right? Now let us calculate my. So my is again 0 to 1. Integration x to 2 minus x square. Then we have, let me take out rho common, and I have x dy dx. So this will give me rho 0 to 1. X is constant for the y integral. So I've already calculated y integral here, and I was getting 2 minus x square minus x, right? So when I multiply it with this term x, let me rewrite it over here. 2 minus x square minus x dx. So I will get rho 0 to 1. This is 2x minus x cube minus x square dx. So let us integrate this. This is rho. 2x will give me 2x square by 2. So that is simply x square. 2x square by 2 is x square minus x cube integration is x4 by 4. And x square integration is x cubed by 3. So let me put the value of rho as 3. The LCM would be 12 when I put the limits 0 to 1. And I will have 1 here. So 1 will give me 12. 3 minus 4. Right? So 3 ones are 3 fours are. Then this is 12 minus 7. So that is 5 by 4. Right? So finally, my point x bar, that is the center of mass, is x bar is my by m. So that is 5 by 4 into m is 2 by 7, right? The opposite of it. So that is 5 by 14, and y bar will turn out to be mx by m. So mx is 19 by 5 into 2 by 7. So that turns out to be 38 by 35, right? So these are your center of. Clear? Okay. So I hope you understood this question. So just the calculations are there, and you can see that once you calculate the limits in one of the integrals, the limits remain same throughout the entire question. Isn't it? Okay. So I'll give you one more question as an exercise. So just try them. You need to calculate the centroid of this region in the first quadrant bounded by the x-axis, the parabola, and the line x plus y equal to 4. I've given you the values here, so do check them and do let me know in the comment section whether you could do that question or not, right? And thank you so much for listening to me. And if you haven't subscribed my channel yet, do subscribe my channel to get the latest updated video. And do hit the like button and do share my channel with others who need them, right? And do believe in yourself, you can definitely do it. Thank you so much and have a nice day.